Hello, it's Mr Baglin again.
Welcome to this online numeracy lesson. Today we're going to be learning about one of the 4 number operations.
Division.
Before we begin, we are going to practice some of our times tables. Are you ready?
Table troopers, where are we?
At the airport, sir.
Hey, table troopers, which table are we tackling today?
The 4 times table, sir.
And why, table troopers, are we tackling the 4 times table?
To help our maths take off, sir.
That's silly. Table troopers, who are you?
Table troopers, learning as we march along. Table troopers, with this 4 times table song.
Right, troopers, marching in multiples of 4. Go! 4, 8, 12, 16.
4, 8, 12, 16.
20, 24, 28, 32.
20, 24, 28, 32.
36, 40, 44, 48.
36, 40, 44, 48.
Troopers only, marching in multiples of 4. Go!
4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48.
Table troopers, learning as we march along. Table troopers, with this 4 times table song.
Right, troopers, time for trooper table facts. 4 times 1 is what?
4 times 1 is 4.
4 times 2 is what?
4 times 2 is 8.
4 times 3 is what?
4 times 3 is 12.
4 times 4 is what?
4 times 4 is 16.
4 times 5 is what?
4 times 5 is 20.
4 times 6 is what?
4 times 6 is 24.
4 times 7 is what?
4 times 7 is 28.
4 times 8 is what?
4 times 8 is 32.
4 times 9 is what?
4 times 9 is 36.
4 times 10 is what?
4 times 10 is 40.
4 times 11 is what?
4 times 11 is 44.
4 times 12 is what?
4 times 12 is 48.
Table troopers, learning as we march along. Table troopers, with this 4 times table song.
Right, troopers, time for trooper table testing. 4 times 2 is what?
4 times 2 is 8.
4 times 10 is what?
4 times 10 is 40.
4 times 6 is what?
4 times 6 is 24.
4 times 11 is what?
4 times 11 is 44.
4 times 5 is what?
4 times 5 is 20.
4 times 9 is what?
4 times 9 is 36.
4 times 1 is what?
4 times 1 is 4.
4 times 8 is what?
4 times 8 is 32.
4 times 12 is what?
4 times 12 is 48.
4 times 3 is what?
4 times 3 is 12.
4 times 7 is what?
4 times 7 is 28.
4 times 4 is what?
4 times 4 is 60.
Table troopers, learning as we march along. Table troopers, with this 4 times table song. Table troopers, learning as we march along. Table troopers, with this 4 times table song.
terrific and tremendously talented table troopers.
Excuse me, sir. Please can I have a cup of tea and a biscuit, sir?
Speak up.
Please can I have a cup of tea and a biscuit, sir? Stupid planes. Go away. Go somewhere else. Don't want planes on this airport anymore.
Did you enjoy Table Troopers? I hope so. We always have lots of fun singing and dancing to it in the classroom. At Parents' Evening, you were all given a home learning pack. Can you find your pencil and some squared paper? First, I would like you to write the target shown below the top of your page. During the lesson, I will be asking you to complete some examples on your sheet of squared paper. I would like you to pause the video. You'll see an icon on the screen like this. When I have given you a task to do, this will give you time to write your answer. Are you ready? In the last lesson, we began to solve more difficult division number problems using short division that involve remainders. I know that you worked really hard to understand this new way of solving division calculations. Some of you may have struggled a little, so I think we need to complete a few more examples, both together and independently.
Okay, we're going to continue our numeracy lesson by practicing our new method of division. The sum we're going to be working with, 56, and I'm dividing it by 3. Okay, now looking at this sum, I'm thinking, 3 times table. Now I don't normally practice my 3 times table up this far. Okay, but it's got a 6 in it, which is in the 3 times table, so maybe there might not be a remainder in this one. The only way we can be absolutely sure is to use our written method. Okay, so for this, we put our number there, big number. This is the number we're dividing. And then we put it inside our division sign for short division. This is the bus stop, if you remember. So the big number goes inside the bus stop. The divisor goes outside. Like that. Okay. Now we need to think how many times this number outside the bracket goes into the first digit of our 2-digit numbers. Okay, so how many lots of 3 are there in 5? How many lots of 3 are there in 5? There's 1, isn't there? Now for this one, we've got to carry all of the examples we did yesterday. We carried 1 into this column. So I don't want you to get into the habit of just going, well, I'm carrying 1 over. It's how many that's left to get us up to this number. So there's 1 lot of 3, but there's how many left over? There's 2, isn't there? We need to add 1, 2 to 3 to get up to that 5. So we need to carry, in this case, a 2 into our column and divide this number, which is now 26, by the 3 that's outside of the bus stop. Okay, so how many lots of 3 are there in 26? Let's count up in our heads. So we've got 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, 3 times 6 is 18, 3 times 7 is, you've got it, 21, 3 times 8 is 24. Now, if I add another 3 to 24, it takes me past this number here, doesn't it? So the number that needs to go above in our bus stop is actually 8. 8 lots of 3 are 24. So we need to keep that 24 in our head now and count up how many have I got left over. 25, 26. I've actually got a remainder of 2 in this one. These methods rely, as I've said before, your growing skills with numeracy. Okay, we're keeping these numbers in our heads rather than writing it down as if it was like an expanded version. So you need to be increasingly secure in your times table. Now, I know I've said that in the previous lesson and the lesson previous to that as well, but it's becoming really evident to me that I need times tables to work these ones out. Okay, you can use your times table knowledge to get yourself to a number, but you'll need to be able to work these out in your head. Okay, so 56 divided by 3 is 18. Remainder 2. We could check our answer. We could multiply this now by 3 to see where we get, whether we get back up to 56. So 3 lots of 10 is 30. 3 lots of 8 is, yep, 24. Well done. 54, and this 2 takes us up to 56. Let's try another one.
Look at this calculation.
Numbers are increasing in our examples. This one we've got 71 divided by 3. We are able to work with bigger numbers, still using the times tables that we know. I've spotted something. I think maybe you might have spotted something slightly different about this one. Let's have a look. So we won't really know until we get into solving this problem. So we've got 71, and we're dividing that by 3 again. Now, I've spotted something different already. How many lots of 3 are there in 7? Correct, there's 2, isn't there? So this is different straight away. All of the examples we've seen, we've had just the divisor going into this first tens digit once. This time we've got it twice. How many have we got left over? 2 lots of 3 is 6, so we've got 1 left over. Okay, so that's a difference straight away. Now we do our division. I've got 11. Now, thinking of my 3 times table, 11 isn't in it. I know 11 isn't in it. So we've got 3, 6, 9, 12. So 3, 6, 9. 3 lots of 3 is 9. So we've got 3 lots of 3. And how many are left over? 9, 10, 11. We've got 2 left over. So this is a trickier one because when we put the divisor into the tens digit, it goes in more than once, but we still have to carry one of these numbers over. Then we do this sum and we have our remainder. So to complete my calculation, 71 divided by 3 is 23, with 2 left over, remainder 2. Now with my 3 times table, I got up to 12 times 3, which I know is 36. So I might think of 13 times 3, 14 times 3. That might be something that you practice. But rarely do we practice our 3 times table up to 23 times. Okay, so that's where we need this formal method to help us to calculate these numbers that are getting bigger and more difficult. Okay, so let's see what the next example holds for us.
Let's look at another calculation.
Okay, another example for us. This time we're going large, and it's 99 divided by 4. And that's got to be a big wow for me. Okay, so really that's where that's the biggest 2-digit number that we could be working with. Okay, so it's really pushing us now. Okay, still a times table that we should be able to work with. Have a little think about it now. What sort of number is 99? Is it odd or even? You got it, it's an odd number, isn't it? We're dividing it by an even number. So do you think there's going to be a remainder or not? No remainder from Summer here? Oh, somebody said there's going to be a remainder. Should we find out? Okay, so just because this number's got bigger, there's no reason why we can't solve it using our bus stop. So the big number, 99, goes inside the bus stop. The divisor goes outside. Okay. So now, just like before, we need to, that's me touching the screen. Just like before, we need to say how many times does the divisor go into the tens digit? So how many lots of 4 are there in 9? Well done. Yeah, definitely. There's 2 lots of 4 in 9. How many left over? Oh, don't shout at once. Definitely, it's 1, isn't it? So we've got 1 left over. So now we need to think of how many lots of 4 are there in 19? Think of your 4 times table. I've got one that's immediately springing to mind. I know that 19 isn't in my 4 times table, but let's just work it out. 4, 8, 12, 16, 20 is the next one, isn't it? So once 4 is 4, 2 4s are 8, 3 4s are 12, 4 4s are 16, and then we've got 17, 18, 19, 3 left over. 99 divided by 4 is 24. Remainder 3. Now, be honest. If you thought that at the start of today's online lesson, you would be dividing such a big number, you wouldn't have believed me, would you? But we have. Well done.
Look at this calculation.
Okay, so this example, we've got 92 and we're dividing it by 8. So it's a slightly smaller 2-digit number. Obviously the biggest 2-digit number we did the last time, 99. But this is using perhaps a more unfamiliar times table. Okay, but there's no reason why we can't calculate that using our bus stop method. So the big number goes inside the bus stop. The divisor goes outside. Okay? And then we solve it just the same. Our divisor, how many times does the divisor go into the tens digit? Okay. And I'm saying the tens digit because it's not actually into 90, it's just a number that's in the tens column. So how many times does our divisor 8 go into the digit 9? There's one lot of 8 in that 9, isn't there? Yeah? How many more do we need to add to 8 to get to 9? Yeah, it's 1. So we need to carry that 1 across into the ones column, don't we? And now the divisor, how many times does 8 go into 12? How many lots of 8 are there in 12? 8's in 12. Yeah, you got it. There's only 1, isn't there? Because if there's 2 8's, that's 16. So we've got a remainder, quite a big remainder this time. How many are left over? 8, 9, 10, 11, 12. 8, 10, 11, 12. That's 4 left over. So using our short division method allows us to divide increasingly large numbers by the timetables that we know. But we're only really dealing with single digit numbers into single digit numbers, or single digits into quite sensible numbers. If we're kind of excuse me, if we're given this number 92, we can get all kind of scared because it's really big. But when you break it down into the different steps of our short division method, we're kind of dealing with an 8 going into 9, and we know that there's only one lot of 8 in 9. And then we're dealing with 12. Okay, so these numbers, the individual numbers that we're actually working with to get to the end result, are really quite small and quite manageable. But again, times tables come into play. Okay, lining up your columns come into play, and your increasing sophistication, that's the increasing knowledge of number, comes into play as well. Okay, I'm going to give you one for you to try on your own, and then we'll do it together. Okay?
Have a go at this calculation on your own. Set it out with the big number inside the bus stop. Then see how many times a divisor, the number outside the bus stop, goes into the tens number. Write your answer on top of the bus stop. Carry any number left over into the ones column and see how many times the divisor goes into that number. And write that answer above the bus stop. Remember, there might be a remainder to include in your answer. Off you go. How did you get on?
So let's see how you did. Okay, so the sum was 53. Divided by 3. So I've chosen a slightly smaller number for us. Okay, and a times table that we've been practicing. I know that you've done this. You've written your 2-digit number there. You've surrounded your 2-digit number with our bus stop. If you remember that this shows or denotes that it's a division sum, sorry. And then outside of the bus stop is where you've put the divisor. Yeah? So whatever's inside is being divided into 3 equal piles, and we need or. Yeah, 3 piles. And we need to know how many are in each pile and if there are any left over. Because when we divide, we share equally. Don't we? That's a definition. You share equally. But sometimes it doesn't share equally. We have a remainder. Let's see if that's the case on this one. So we look, the divisor is 3. The 10th digit is 5. How many times does 3 go into 5? Yeah, I'm convinced that you've got that one right. How many have I got left over? How many am I putting into this ones column? 3, 5. So I need to carry over 2 into our ones column. So now we're dividing 23 by 3. So let's do it. Let's count up in threes. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. 3 times 6 is 18. 3 times 7 is 21. 3 times 8 is 24. Oh, so it can't be 8 times because that would take us past this number. Okay, so it's got to be 3 times 7. 7 lots of 3. 3 sevens are 21. Quite right. So it's got to be a 7 that goes in there. 7 lots of 3 is 21. What's my remainder? How many have I got left over? Yep, you've got it. Remainder 2. So completing my calculation, 17, remainder 2. Now we could try and think of ways, let's try and think of ways that might have gone wrong. By the way, give yourself a massive pat on the back if you got that answer correct. If you did that on your own, you're doing really, really well. And I mean really, really well. Where might we have gone wrong? We might have got into the habit of just going, let's just pop it here. Let's choose a different color, different thickness. So maybe our sum might have looked like about 53 divided by 3. We might have said, okay, threes, how many threes? We might have got that bit right. But we might have thought, well, we always carry a 1 over. We always do that. It's been a 1 all of yesterday or all of the day before or all of the ones I've seen before. So we just do that. And then you go 3s into 13. Okay, so you might say, okay, that's 4. And then you've got 1 left over because I know it's 12. So if you get this carrying bit wrong here, it can give you a completely different answer. Because 3 14s is 30, 42, 43. And we've actually got 53. We're 10 away, aren't we? So that's one possible way that it might have gone wrong. What's another way that it could have gone wrong? Just trying to think. You might have forgotten the remainder altogether. That might be a way. You might not have bothered to put this bit in here. So you might have had you might have gone 53 divided by 3. You might have got this bit wrong, but I can't begin to imagine my numeracy pals that you'd get the 3 going into 5 a little bit wrong. Okay, but you might have gone 3s into 5 is 2. Don't think so. No, I'm not even going to begin to entertain that one. And then you might have forgotten to carry over anything and gone 3s into 3 is 1. I know that there's one lot of 3 in 3, so my answer is 11 with no remainder. Yeah, that might have been 1. You might have gone, let's choose one last color, perhaps. You might have done it all correctly. 3s into 5 is 1. You might have carried over your 2, gone 3s into 23 is 7, but then just forgotten to put the remainder in. That might have been one possible way that we've gone wrong. Check yours to make sure it looks like mine. If it does, and you've done that on your own, that's fab. That's absolutely fantastic. If not, where have you gone wrong, and can you make yours look like mine? Because we're going to try some independently.
Your target today is I can use short division to solve division number problems, including remainders. Set it out with the big number inside the bus stop. Then see how many times a divisor, the number outside the bus stop, goes into the tens number. Write your answer on top of the bus stop. Carry any number left over into the ones column and see how many times the divisor goes into that number. And write that answer above the bus stop. Remember, there might be a remainder to include in your answer. Your target today is I can use short division to solve division number problems, including remainders. Follow these steps to ensure that you're successful. Set out the calculation with the big number inside the bus stop. Then see how many times a divisor goes into the tens number. Write your answer on top of the bus stop. Carry any number left over into the ones column and see how many times the divisor goes into that number. Then write that answer above the bus stop. Remember, there might be a remainder to include in your answer. When you have finished, check your work against the answers on the next page. Did you meet the criteria? How did you get on? If you would like to complete some independent work, then log on to TT Rockstars for times tables or Purple Mash for some maths games. Thank you for your hard work today. I would love to see the results of your hard work. Send your calculations to me at school. You can use any of the ways you can see on the screen: WhatsApp, email or postbox. I'll see you again soon for some more numeracy tomfoolery.